So as I said, we're moving in here to talk about systems of nonlinear equations. In particular, we're going to look at nonlinear equations in 2 variables. 3 variables would have the same process, the same issues as they did with linear things. So it's a bit of complexity beyond us here, beyond most classes, really. But anyway, when we're talking about these things, we're talking about things where the powers of x and y, our 2 variables, are not just 0 and 1, and sometimes we even multiply them next to each other, multiply them into each other. We might have things like x squared equals 2y plus 10 and 3x minus y equals 9, where because in that first part we have the squared, you can't put that in the form ax plus by equals c. Or similarly, we might have 2 different things that are quadratic in flavor. Y equals x squared plus 3, or x squared plus y squared equals 9. Or actually, that second one's not quite quadratic, it's more of a circle, but you get the idea there that we're not just talking about our simple linear terms. We got more exponents, we got more complexity, we got more polynomial flavored things, although we're generally not going to go higher than degree 2 here, just to keep things fairly simple in the approach, where the approach actually isn't all that different. We're still talking about substitution, we're still talking about addition, and we're still getting very similar results, albeit with more values than before, because unlike points that can only intersect at one unique location, you can have multiple places that parabolas and circles and hyperbolas and all the conic sections can hit lines and other conics, as it were, as we're going to see here, starting with substitution.